Third one, no, not the third one.
Second.
Seriously, y'all?
The
If I
one,
ask you to find the roots,
the one with the square root sign.
square root signs, here's the difference. Where can you get this from? From the graph. I'm not asking you to find it from the graph because that's an approximation. It's not an exact value. When I ask you to find the roots, we're not just graphing it to find it, right? Those are approximations. Find the roots of the following equation. Just write the equivalent equation. Don't show inverses, zeros, product, property, all that stuff. So I am starting out with this equation. And this is a detail on the test that we struggle with, which is why I assigned some homework that's due next Tuesday, or I guess I'll give y'all a sheet today. That's due next Tuesday to help you get better at this skill. But how am I supposed to solve this equation? What do I need to do first to get the roots? Okay, first off, remember, we need it equal to 0. We need zeros, right, or x-intercepts or roots. And then I'm going to graph it to try to find what? Which form to use. So like if I have nice x-intercepts, which what do we mean by nice x-intercepts? Probably not decimals. They could be rational decimals, right? Like they're terminating or something like that. And so I do want to point that out. A lot of us on the test just said, hey, if it's a nice x-intercept, I'm going to use factored form. Clarify what that means, right? So we want those integer roots, or we want the rational roots. But did we have nice roots on this one? No. You can see that right here. Did we have a nice vertex though? Meaning integer values on the vertex. So remember, because a lot of us are skipping this step, this will help you think about what you need to know. So, DJ, do I need to graph it to identify any points on here?
Yes.
Or, sorry, let me clarify. Do I need to graph it to and find points to figure out what A is? No. Remember, if you are given the equation, does standard form have an A on it? It's understood to be 1. It's not written there because it's understood to be 1. I already know what A is. I don't have to solve for it. What was our value for H?
-3.
-3.
See, where does that come from? The vertex.
When you graph it.
Okay, so when you graph it, you go to analyze graph and then.
Right, so remember, like, and here's the issue. If you hit menu right now, it will not let you analyze the graph because you're not actually clicked on the graph. You're clicked on the text box. You have to click on the graph. You'll see that it's highlighted in blue. And now when I hit menu and I do analyze graph, now I can do a minimum. And there it is, -3, -5. We good on that? Okay. I'm going to undo that so that it's not there when you send it out to the third block. So yeah, x minus a -3, so I'm going to end up adding squared minus 5. That is an equation I can solve using what principles? You could, but I wouldn't. Properties of equality with, there's an important I word. Say again? Non-interval.
Inverse.
Inverses, right? We use inverses to solve equations.
What is it?
Anybody want to tell me what the first inverse I should use is?
+5.
Plus 5.
Oh, well, we could just say addition.
But is it always addition?
No, but like on this one, like if you said, like, what's the first step? I would say +5. So
But the point is you're trying to memorize individual steps instead of look at the big picture. What is the big picture? What is the thing that we always use? Inverses to create those zeros and ones, along with the properties of equality to make sure the equations are equivalent. 5 is equal to, do I need to write the 1? No, so I'm not even going to write the 1 so I don't have to divide or anything like that. But now I need to square root it. Again, this is why I say inverses, because it's not always going to be addition. It's not always going to be division or multiplication, but it is going to be the inverse. The square root and the square cancel each other out, and so I get the square root of 5 is equal to x plus 3. Am I good to go? What's wrong? Thank you. Whenever I take that square root, it's got to be a plus or minus. And now what do I need to do? Subtract that 3. -3 plus or minus the square root of 5. Remember, the calculator won't accept it written that way, so you have to do -3 plus the square root of 5 and -3 minus the square root of 5.
I think it's just weird to me because it feels like it's not all the way solved. Because like when I would do it, I would like square literally like x plus and then 3, whatever 3 squared is, and then I would do like, you know, like
That's very incorrect
the
though.
whole thing.
That's very incorrect though.
But that's how we always do it.
No, that's not.
It is.
Nope, you're misremembering. This is why I go into detail about exactly how and why. If you square this, first off, what does it mean to square? Multiply it by itself. You would not get x squared plus 9. You would not get x squared plus 9. What would I need to do to square this, to multiply it by itself? I would have to distribute, which that does give me an x squared. But then what's x times 3? 3x. What's x times, or 3 times x? So do you just get x squared plus 9? No. So can we square it? No. We don't want to square it. That's why we need an inverse, because I'm right back to standard form. Can we solve an equation in standard form? No. That's why we need inverses when we have that vertex form. You have to use inverses when you have vertex form.
I just want you to know that I look so stupid on the test because this just like slipped my mind. I do vertex form.
So don't forget, I'm going to give you all a chance to do test corrections, which I don't have y'all's tests done because I started doing feedback to help you do test corrections. I'll have them done after second block today, so if you want to come back by and get your test to start on your test corrections and do a retest next week, you can do that. I'll also have the retest created by the end of today, so you can do the retest whenever you want, but that's okay. Remember, my thing is not that you have to know at a certain point. It's growing and learning and improving, right? So the retest, I will say, don't forget, it will have the same exact concepts, but will it have the same exact problems? No. So like, you have to understand so that you can apply. All right. So we had trouble, technology difficulties. I'll fix it for the future, but I do want to point out domain. Remember, this is something we started really talking about heavily yesterday. Domain refers to which variable? X. So what is the minimum x value? Listen to this important question. For the function, not the window, for the function. Is it going to continue going to the left? Is it ever going to stop going to the left? Nope.
See, I didn't get that. I was thinking, you know how the other one like came off the graph and then left off the graph? That's why I bought negative infinity, positive infinity. But this one, it does have like a point that it stops. But I wasn't thinking of the fact of the two sides of it.
Right, but remember, domain is, and this is why it's important, domain only refers to which variable? X. So I shouldn't be thinking up versus down. I should be thinking left versus right. It's going up, but it's also going to the left because of that angle. We know that. Same over here. It's angled, so it is going up, but it's also going to the right. So the minimum would be negative infinity. How do I determine when I put a parenthesis versus a bracket?
When it's equal.
When it's equal to, I use a bracket. So can I equal negative infinity? So I need a parenthesis. KJ, you good on that? Good? Okay. So I cannot equal negative infinity, I'm going to use a parenthesis. And it's going up and to the right, so what is the maximum x value? Infinity. There we go. Range. A lot of y'all made this one more difficult than it is. Did you notice that this is the same function as what we had on 1.1? It's exactly the same if you go back and look. What was the vertex on that one? I think it was -3, -5. So what is my minimum y value? -5. So -5 goes here. What goes with that -5?
0.
Well, hold on. What needs to go before the -5? That's what I'm asking. Can I equal the -5?
Oh, yeah.
See how I have a clear point at -5, so is it equal to -5?
Yes.
So it's a bracket, and then don't forget we put a comma, and then what? Infinity. Because notice, is it going to stop going up? So that maximum range value, the maximum y is infinity. We good on that one?
What do you mean by like X and Y? Like,
X, y. So remember, when we're talking about the y, and that's just the y-axis, but that's how I identify the y values, right? So if you look at this graph right here, what is the lowest y value? Does it ever go below this point? Does that graph ever go below that point?
oh, so you mean like the one that's lowest
Lowest.
from the Y?
Right, and that's why you have to separate the x from the y. When I'm talking about domain, I'm only talking about left versus right. When I'm talking about range, I'm only talking about bottom to top.
That was one of my main problems, is like
Okay.
X is used as a variable a lot, but I was always thinking X on a graph, but then sometimes it wasn't referring to X on a graph.
So, well, here's the thing, what I'm talking about, and if you look back at the definition that I talked about yesterday in the textbook that we wrote down, or should have written down, I talked about x values, but I said more importantly, it's all inputs, right? Because it doesn't have to be x depending on the variable we use, but it's any number you can plug into the equation. Well, because it's going up and to the left, the lowest value that I could plug in for x, or the input, is that negative infinity, right? The biggest x value I could substitute in, because it's going to the right forever, is that positive infinity. But the range is, right, remember, is bottom to top, so what is the lowest y value that I ever get out, right? Domain is input, range is output. What's the lowest y value I ever get out? -5. Right, it doesn't go below that on this graph. But it goes all the way up to positive infinity. We good on that?
Mhm.
Any questions there? Okay, just taking a minute or so to look at 1.3, just kind of curious what y'all said on this. Because you tell us to count things in the real world, to expand our language, help us solve real world problems, to understand and expand our minds, to use real world equations, to understand it, you need the credit to graduate, okay? No, I mean, like, some of these are valid. You want to know something really interesting? For all of you who said to solve real world problems, can we solve real world problems with the math we're learning? Yes. How many of you are going to throughout your life? Probably not many. Engineering, maybe. Please understand, because I think this is where some of us get frustrated with some of the math, is that we know, or we've heard other teachers say, hey, you're going to use this in the real world. Algebra 2 and up, that's bullcrap, right? Like, as an engineer, in engineering I did. Some business principles are built on these mathematical ideas. So we can't go into this saying, hey, I'm going to use this to solve real world problems. It's not very common. But what is true is, and I like this idea, to understand, and I'll stop here, expand our minds. When you learn to think, and when you learn to grow, you're going to be better prepared for life. Notice, I am teaching you math, but I'm teaching you this content to get you to think, and to get you to expand your minds, to get you to learn, because those principles are things you're going to use in your everyday life. The other thing, and I do want you to hear me very clearly on this, is there's beauty within mathematics. There's a lot of structure, there's a lot of patterns, and when we discover those patterns, the math becomes more beautiful and we can appreciate it more. If you approach it as 1,000 rules, because there are lots and lots and lots of rules, if you approach it as 1,000 rules, it becomes overwhelming and it sucks. I did not love math like I do now until I started to look at it as patterns to discover and to understand. So if you come to math as, hey, I'm going to memorize these rules, it sucks. It really does. When you come at it as, hey, there's a pattern here, let's figure out how these patterns go together, it is way more fun and you can enjoy it. So that's my challenge to you today. Alright?
When we graduate, are they gonna teach us like how to do our taxes or something?
Oh yeah, someone actually brought that up in
I'm
third
gonna
block.
accidentally commit tax fraud.
No.
On
Y'all,
accident.
no one needs to know how to do taxes, because 1, math is not taxes. 2, there's an egregious tax code that no one should ever learn. 3, there's this thing called TurboTax and H&R Block, and you literally plug numbers in and it does it for you.
My parents get some Anybody do a tax?
And there are accountants, there are people who have to go to school for 4 years or more to be able to do taxes. You are never going to do taxes on your own. Don't worry about it.
Did it send you a number and say like you overpaid, you underpaid?
So you get your payment, so you get a bunch of information at the end of the year of like your tax stubs and like how much you were total paid and how much you paid in taxes. And then it does the calculations for you. You also put information in about how much you gave to charities, how much you did this and that and the other, and it does deductions or whatever. But that's what I'm saying, it is too complicated for anyone to do on their own. Yes, ma'am?
Can I go to the bathroom before we start?
Yeah, I mean, you can go to the bathroom, we're starting though.
My mom's gonna do my taxes. She's an accountant, she already volunteered, so I'm gonna let her do it.
Yeah, I mean, like, that's the thing.
She
No,
enjoys that
no
kind of
one is
stuff.
going to be doing their taxes on their own. Don't even think like that. That's just silliness. Alright, so we are going to finish up topic 2, lesson 4, the zeros to hero, and looking at activity 4.3. This is all about, any guesses?
Zero.
Zeros, right? Or other words are roots and x-intercepts. It's involving polynomial functions, yes. Any guesses when we get to lesson 1 in topic 3? So notice we're going to actually jump a good bit to get to topic 3. What are we going to be learning about in that lesson?
Even and odd ones.
So odd, I can't even. There is something called odd and even functions. We're skipping that part. We're focusing on what? In behavior. Right? We're going to talk about that there. 2.1, we're going to actually properly define what a polynomial function is. And quartic and quintic is just going beyond cubic. Right? So we'll talk about that there. And then we're going to get to key characteristics of polynomials. Please hear me very clearly on this. We have a short class tomorrow. So we're going to probably skip the bell ringer tomorrow, and we're going to jump straight into working because 1, we need to finish up these lessons. 2, I need to get you all started on your math or your literacy for all because that's going to be due on Friday.
Oh, is that why it's a short class?
No, y'all have a short class because we got Veterans Day.
Veterans Day.
Uh-huh.
What's the point
In
of
the gym or
the
something?
problem?
Like during.
Huh?
You gotta do math literacy.
No, it's during.
Literacy for all. It's where you read an article and you write it.
What's the point of you gotta read?
What's the point of literacy for all? There's a really good intention. Okay, hold on. There's a really good intention that the ACT used to have a mandatory writing component. No one today, as far as I can tell, requires the writing component. Because it is a terrible measure of how good of a writer you are. Now, I will also say, there is a good element of learning to read, analyze, and develop your ideas. Y'all won't see it, but like in the past, I used to have my students write research papers in a math class.
I like the math literacy. It's actually like, it feels like useful math, like they'll have the chart and it'll be like all the SAT
Yeah,
score
fun
and
fact,
you'll be
that's
like-
not math at all, it's not math literacy, it's graphical literacy.
Well, yeah, that,
But-
but aren't graphs part of math?
Not, I mean, those kinds of graphs are a part of statistics, not
This is the
about,
class we're in.
well, so let's clarify, statistics is a mathematical science, which means it's more of a science than it is a math, they are related, we'll get into that later
Well, that I
at
feel
other
like I
points,
can
but we gotta
understand.
do this now.
Um,
So, we talked about, no wait, I skipped part of, hold on, I gotta go get,
What page are you
that's a good question.
It's 169. That's the
on?
last.
Oh, we are on this. I was covering
Just don't like block schedule, because I know by next year, once I've had a whole half of the year of not doing math, I'm gonna forget every single
Yeah,
thing.
it's the worst. But, so we already talked about these degrees. What do we mean by degrees of a function?
Exponents.
Yeah, how many X?
Go a little bit more detail.
Power of
Okay, so like, would this be a degree 1?
No. Degree 2 is squared.
So degree 2 is squared, but like, I don't have anything squared right now.
But there's two
X.
It's,
two X.
the two x's are being
multiplied.
multiplied, so if I were to distribute the x, what would I get?
X.
Minus,
Minus.
not minus 1, minus x, right? You said distribute. What's x times x? X squared. What's x times negative 1?
Oh, then.
Minus x.
Oh.
Pay attention, distribute, okay? So it's not degree 1, it is degree 2. I will also remind you that you can just pay attention to how many linear factors you have. Because each linear factor is x to the first. So if I'm multiplying two linear factors, it's going to be a degree 2. If I'm multiplying three linear factors, it's going to be degree 3. It's going to be a cubic or degree 3. We all good with that idea?
Yes.
Okay? Yesterday, we also then started to talk about the multiplicity of these factors. So here. Alright, so the number of zeros and the multiplicity of those zeros. And so this is a little bit of difficulty. Y'all didn't love this at first, but remember, if it's a 0, that factor, what do we substitute in for the y? 0. So what is the only 0 in this case? Well, x equals 0. How many times does that 0 show up? Once. So the multiplicity was what? 1. And so then we come over to here. Again, 0 is equal to x minus 1. So what is my 0? X equals what?
1.
Right? And what's the multiplicity of that 0? 1. It only showed up one time.
So we're basically just looking at how many x's there are.
How many times that factor shows up. So let's, and what we ended yesterday on was D, right? Notice this would be 0 is equal to x minus 1 times x minus 1. So technically 0 is equal to x minus 1 and 0 is equal to x minus 1, but that means x is equal to what? How much?
X
One.
equal 1.
X is equal to 1, don't make it more difficult than that. But how many times is x equal to 1? 2, so it would be a multiplicity of 2.
So if this is x squared, we just, like if it's only x squared one time, we just say it'd be the,
So you
degree 1, like you wouldn't say degree 2 because x is being squared.
Actually, if it was x squared, you have to think about it as factors. Isn't x squared x times x?
Yeah, but that's what I'm
Hold
saying,
on.
one of them,
But that's not x squared.
no, not that one, what's the one we just did? That was
This one?
Yeah, the one right there. Multiplicity.
But notice, that was x squared minus x. You have to have it as factors, because what can I use once I get factors? Well, I already have the factors. What property can I use?
Zero product.
Zero product property. So I would say 0 is equal to x and 0 is equal to x. You have to have it factored. You can't distribute it to get the zeros, right? So when I do 0 is equal to x and 0 is equal to x minus 1, that's not the same root. Those are two different roots, right? One of them is x equals 0, and then here, 1 is equal to x. How many times did each of those show up? That showed up twice?
Oh, no.
It was only how many times?
What?
Once. How many times did that show up?
What?
Once. So both have a multiplicity of what? Of 1. They each only showed up once.
That's weird, I'm not gonna, I feel like I'm gonna be confused on that later if it's like, what about like the.
So I'm going to let y'all actually work on E and F for a couple minutes, and then I'm going to give you some important notes to keep in mind about it. But work within your groups, try to answer E and F, right? Or no, do number 2, identifying the zeros and the multiplicity, and then we're going to talk about number 3 as a whole class. But let's get to work.
We didn't do the multiplicity.
We already did degrees for E and F, we did not do the multiplicity and the zeros. So remember, I'm asking you to do, so like I would do E and F over here, I'm asking you to identify the number of zeros and the multiplicity of each zero.
Okay.
So we got
No, you do E and F, but you've already done degree. What I'm asking you to find is the zeros and the multiplicity of those
Does that mean
zeros.
the multiplicity?
So like, first off, what would I do to figure out the
I mean,
zeros for E?
Like every time.
Make it equal to 0, it's literally a 0.
That means that there's.
Times x,
two
times x minus
x's
1,
and
times
those
x minus
zeros
1, right?
equal them, so-
So then what do I now need to do to figure out what the zeros are? No. It's factored. What property can I use? No. Listen to the question again. what property can I use since it's factored and equal to
See,
0?
that's what confuses me is they.
Zero product property. So that means 0 is equal to,
Squared.
why are you skipping that x? Could 0 equal that x?
That's what I'm asking.
Like if x was 0, could you do 0 times whatever and get 0? So 0 is equal to x, that is a 0.
So,
And then 0 is also equal to
It's not counted as 2 because it's
x minus 1.
2x, yeah.
Now solve for your zeros, right? Because that's the same thing, so you don't have to rewrite it. Solve for your zeros there. How are we doing? We don't know? So what'd you do? Okay. So you set your equation equal to 0, right? Because we're looking for zeros. You set each factor equal to 0. Now solve for your zeros. Yeah. So you do want them a little spread out so you can solve them.
Everything I'm done.
It's already solved. You don't have to do anything.
For E, what is x equal to?
So I guess you would.
So you're done. Right? X is equal to 0. Do y'all have any questions before I leave and go check on other groups?
Zero. X equals 1, or those are zeros.
That is one of them. Don't do that x squared minus x though. Remember, I just said it has to be factored, because what property can you use when it's
I
factored
don't know, but
and equal to 0?
degree of 1 is multiplicity of 1. Degree of
Zero
2
product
is
property.
multiplicity of 2.
It's already factored, so I can use zero product property. So 0 is equal to x, and
Unless you
0
solve
is equal
something
to
like it's 9 or something.
x minus 1. So how many times did this 0 show up?
Like, how did you get?
Once, so that multiplicity is 1. What would I do to finish solving for x here?
First year, you take it out. Like, do you do both?
1 is equal to x. How many times did that 0 show up? Twice. So what's that multiplicity? That one only showed up how many times? So the multiplicity is,
Yes, you can.
I was trying to go up.
yeah, right? That 0 only showed up once, so that multiplicity is 1. That one showed up twice, so the multiplicity is 2.
What's it called in your hair? Like.
How's it going? You haven't finished. Or she hasn't, you haven't either. Look, 0 is equal to x minus 1. You've started, but have you found the zeros? You gotta add the 1. 1 is equal to x. That's a 0, that's a root. And then identify your multiplicity. We'll talk about it in a second. What's up? Yeah, don't do that.
You know that,
Remember, 0 is equal to x times x minus 1 times x minus 1. Don't distribute. First off, if you distributed, it would only be x, you would only distribute it once, that'd be x squared minus x, and then x minus 1, right? And then you would distribute again. Don't do that though.
Whatever that's.
If you have it factored out and equal to 0, what property can you use?
But if you don't
And then we
use
get
it,
to this.
then it should, they should just divide everything.
Or it's points.
And you don't even.
The zero product property.
I didn't.
See, I want to point this out. You already have all this solved, right? So you could have figured out how to solve it from him. You could have figured out the name of the zero product property from him.
Like, it's a good way for teams like.
This is why we talk with each other to help each other out. All right, let's have a whole class conversation. The final answer? I'm gonna talk about it. All right. So let me know if you have any questions after I go over these details, but looking at the very first one, once again, yeah, I'm just gonna do it here. So E, K of x is equal to x times x minus 1 times x minus 1. I'm looking for a 0, so what's the first step?
0.
Make sure it's equal to 0. Do not distribute. Because now that it's factored, what property can I use? Zero product property. Every time. And so if you don't remember that detail, make a note off to the side either here or wherever. You need to have the note when the polynomial, again we're going to define polynomial a little bit more clearly in a second, but when the polynomial is factored, poly means multiple. Mm-hmm.
Like polyamorous. People have like multiple.
Yep, or polytheistic
That's
or
the only
something like
way I
that.
could remember.
So when the polynomial is factored and equal to 0, Use the zero product property. Do I need to remind you what the zero product property says, or do we remember that? Now the question is, do we know what it says, or do we know how to use it? We know how to use it? Both. Remember that the principle is this. If I am multiplying, in order to get a 0, I have to multiply by what number? That's the zero product property. In order to get 0 when multiplying, I had to multiply by 0. That's why we then set each factor to equal to 0, because that could have equaled 0. That could have equaled what?
0.
Now I saw some of us then write this one equal to 0. Do I need to write both of those though? No.
But can't.
Can you? Yes. But I want you to be careful about how we would finish writing it. Do I need to do anything here?
No.
No, I already know what x is. Here, I'm going to add 1, I'm going to add 1, and so x, or 1 is equal to x. I would stop here, and I would just write my multiplicity. Because how many times did x minus 1 show up?
Twice.
So the multiplicity is? That's all that we want to recognize, is that x minus 1 equals 0, so x equals 1 twice, a multiplicity of 2.
Oh, I got that.
I don't have to rewrite it. What's your confusion, DJ? Okay? Now, I do want to clarify, there is one more thing. This would have a multiplicity of what?
One.
Multiplicity of 1.
So like.
Is that was what was bugging you?
The like terms
Mm-hmm.
are like.
Like- Let's not call them like terms. You talking about these things?
Yeah, like in my head.
Because, I know, but because they're being multiplied, what would they be called? It's an F word.
Factors.
Factors. Right? The like factors
Yeah.
would have the same zeros or the same roots.
So like if it's 1 and 1, that's multiplicity of 2, and since that's a 0, it's only multiplicity of 1.
Because it only showed up one time.
Yeah.
And so you may want to make that note here, like factors give us higher multiplicities. Right? That is an important detail to notice, is if the factor is the same, that's when I'm going to get a higher multiplicity. When the factor is the same, you're going to get a higher multiplicity. If I have 2 of the same factor, the multiplicity is 2. If I have 5 of the same factor, what's the multiplicity? 5. That's all there is to it. Okay?
So like on a test,
Mm-hmm.
if we had like say we had a problem like this, you put it over it, but would we have to write the 2 different multiplicities?
Mm-hmm.
Okay.
Because they're 2 different zeros, so you have to identify the multiplicities for each 0. If you had 4 different zeros, you would have to do the multiplicity for each 0.
Okay.
Yes, Cameron?
So I know how to get those numbers, like 0 equals x and 1 equals x, but like, if it's 0, then how is it 1? Like, how is 1 2? Like,
Well, so remember, the 0 is 0, but how many times do we get that 0? The multiplicity indicates how many times we get that root.
Then how do you get 1 twice?
Because how many
Ah,
would I get?
okay.
Does that explain that?
I was confused.
Does that make sense now though?